Welcome to lesson 11.4, Pythagorean Theorem. The Pythagorean Theorem is a formula that we use to find sides in a right triangle. So we first need to know a little bit about a right triangle. You'll remember that a right triangle has one right angle, and then we call the two sides legs. The two sides that are touching the right angle are the legs of the right triangle. And the side that is across from the right angle is called hypotenuse. And the hypotenuse is always going to be the longest side. It has to be the longest side of the right triangle. It's always the one that is across from the right angle. Not touching the right angle, but across from it. So, long time ago, the Greek mathematician Pythagoras figured out that if you have a right triangle, there's a formula for finding the sides. So in a right triangle, we're going to call the legs A and B to work with the Pythagorean theorem, and the hypotenuse is always C. So you just have to remember that this one is always the hypotenuse. And the formula is that a squared plus b squared is going to be equal to c squared. That's the formula that is the Pythagorean theorem, and it's the formula that we're going to use to find missing sides in this right triangle. So it works like this. If I give you a right triangle and I was to tell you that this side is 8 and this side is 15, I want to find the hypotenuse. This is example 1, which is finding the hypotenuse. So the C, we always set it separate from the other two sides in the Pythagorean theorem. So the C squared equals the A squared plus B squared. So in this problem, C squared equals 8 squared plus 15 squared. Doesn't really matter which one's A and which one's B. They're interchangeable, but always have C alone in this formula. So C squared is going to equal 64 plus 225. C squared equals 289 when I add those together. Now, to find C, what we're going to do is take this, I'm going to rewrite this. We have to take the square root of both sides of this equation. So I'm taking the square root here and the square root here. And the square root of C squared is just plain C. The square root of 289, it happens to be a perfect square, and it is 17. So if you didn't know that, you need to be familiar with the perfect squares to do that. But if you didn't know it, you're going to have to experiment with it until you find that it is 17. In the next example, number 2, this time we're going to find a leg, or find a side, and not the hypotenuse. We're going to be given the hypotenuse. So I don't know this side. This one's 10, and the hypotenuse is 25. So once again, we're setting up C squared equals A squared plus B squared. This time we know that C is 25. So 25 squared equals A squared plus 10 squared. 25 squared is 625 equals A squared plus 100. To get A alone, I'm going to subtract 100 and get 525 equals A squared. I'm now going to have to take the square root of both sides. So I have the square root of a squared is just plain a. A equals the square root of 525. And I'm going to have to simplify my square roots. So I'm always going to make sure that you guys are simplifying your answers. The radical I have here, I have to simplify. I'm going to first break it down to radical 5 times radical 105. I believe that's correct. Yeah. Rad 5 stays the same. Rad 105 is 5 times 21. Now I have rad 5 times rad 5, and I'm going to break rad 21 to 3 times 7. So those don't break down anymore. They're not perfect squares, so we're going to bring them back together. Rad 5 times rad 5 is just plain 5. So my answer is C equals 5 rad 21. Now the book always is asking you to do it on a calculator and do 5 times rad 21 on a calculator and then round off your answer to the 100th or the 10th. But we generally are not going to be having calculators. You can check it that way if you want, but I'm going to want a simplified radical. Next example, number 3. This time I'm going to do another one where we're going to find the hypotenuse. So we're going to find C. This side is 6, this side is 8. C squared equals A squared plus B squared. So C squared equals 6 squared plus 8 squared. C squared equals 36 plus 64. C squared equals 100. And now I am taking the square root of both sides. So I have just plain C equals 10. Nice and easy. Now a little bit harder. This time I'm going to call this side X, this side 5, and this 5 radical 3. And use the same formula. C squared equals A squared plus B squared. So this time it's 5 radical 3 squared equals, and in this case A is my X, so I'll just call it X squared plus 5 squared. I have to square 5 radical 3. So remember that means 5 radical 3 times 5 radical 3. I'm going to multiply the 5, and the 5 is 25. And rad 3 times rad 3 is just plain 3. So I'm really doing 25 times 3, which would be 75, equals x squared plus 25. Subtract 25, and I get x squared equals 50. And then I have to take the square root of both sides. X equals rad 50, which is rad 25 times rad 2, which would be 5 rad 2. And that would be your answer. Next one. Now there's a couple of the problems are going to say, the directions will now say determine if, let's see how they wrote it. Determine if this is a right triangle, if these 3 sides form a right triangle. So, in order to do this, I'm going to give the sides would be 6, 4, and 9. In order to do this, we're going to use c squared equals a squared plus b squared, but the longest side always has to be c. So I've got to put 9 in that place of c. So I'm determining, does 9 squared equal 6 squared plus 4 squared? 9 squared is 81, 6 squared is 36, plus 16 36 plus 16 is 52. So no, because these are not equal, this is not a right triangle. Let's try another one. This is number 6. 15, rad 31, and 16. So I first need to know which is the longest side, which is most likely 16, but you got to make sure that you got to estimate what rad 31 would be to make sure it's smaller. So rad 31 is somewhere in between radical 36 and radical 25. Radical 36 is 6, radical 25 is 5. So it's 5 point something. So it's definitely the smallest side. So I'm going to put the 16 alone. C squared equals A squared plus B squared. 16 squared equals A squared plus, oh, I'm sorry, do that right. We know all the sides and we're trying to determine if it's right. So 16 squared, does that equal 15 squared plus 31 squared? 16 squared is 256. 15 squared is 225. And rad 31 squared is just plain 31. So when I add these together, I get 256. So since 256 equals 256, yes, that was a right triangle. Okay, you now have problems to do. Let's see. You're going to do page 854, top of the page, because we're on section 11.4, and you're doing 1, 2, 4, and 7. So your answers need to be simplified radicals. It may say to round off the answers, but we're not going to be using calculators, so just put your answer as a simplified radical. Okay.